And let's introduce our next speaker. I'd like to introduce Lakshya Dubey, and he's speaking on Yara for hunting malwares. So Lakshya, let's see, there we go, you are connected.
Okay, should I share my screen now?
It's kind of hard to hear you. Not sure where your microphone is, but
Should I share my screen now?
no, we can't hear you.
Are you? You can hear me now?
Oh, yeah, there you go. That's much better.
Okay. So, should I share my screen?
Yeah.
Okay. Is it visible now?
Perfect. Yes, we can hear you, we can see you, and we see your screen. Thank
Okay.
you.
So, should I start my session?
Yep, go ahead.
Okay.
Thank you.
Okay, so welcome to my talk on hunting malwares using Yara. So, good morning, afternoon, and evening, depending on where are you from. And firstly, I will actually like to want to thank you all for taking time to attend this talk. So in this computer era, one of the most difficult thing to do is to look for adversaries in our environment. So basically, this advanced adversaries like malwares have good and innovative persistence techniques and have the ability to stay under the radar. So in this session, we will talk about how can we identify these advanced adversaries like malware using Yara. So little bit about me. I am an undergrad student, have a deep interest in malware analysis, memory forensic and threat intel, and I am also a active chapter lead for OWASP Bhopal, OWASP chapter in India. Okay, so let's see about what are we going to talk about today. So we will start with what Yara is and what are its uses and all. Then we will move towards creating our own Yara rules, and we will also look towards an art of building some resilient tool. And we will then move forward towards a demonstration and work with some live malware samples. And then we will also look over a tool which can help us in creating our Yara rules automatically. And then we will conclude with some final thoughts. Okay, so little introduction about Yara. It's a pattern matching tool, basically mostly used by malware researchers and used in malware detection. It's a rule-based approach for creating descriptions. So basically, descriptions consist of strings and all, which we will be looking forward. And Yara can also be used in classifying malwares on the basis of malware families. So it's a most common tools for malware researchers to classify malwares and detect them. And most important one, it's a free and open source tool. So it's developed and used by Virus Total. So it's a best in the field for detecting and classifying malwares. So let's look over purpose of Yara. So as discussed before, it's a important tool in classifying malwares on the basis of malware families and variants. And other than this, Yara can also be used in tracking malware campaigns on the basis of strings and C2 servers, domain IPs, and all. And not only limited to this, Yara can also be used to create your own antivirus, antivirus based on signature. And other than this, Yara is mostly used in the field of memory forensics and incident response too. So why Yara? So before Yara, it was very difficult for the researchers to detect and classify large volumes of malware samples. And basically, as we will see over here in our demonstration, that Yara can effectively be used in around thousands or terabytes of malware samples, and it can effectively generate positive results, which are in the form of detecting malwares. And other than this, it's a completely text or hexadecimal based rules. So it is very easy for a developer to quickly adopt on Yara to create their own rules, and they are so easy to use. Like you can easily pass this rule in your SOC or IDS. So it's just a very easy way to detect this malicious activity in an environment. So let's see over how can we create our Yara rules, or what all we need to create this kind of rules. So basically Yara rules required URLs, IP addresses, file names and hashes, emails and other strings which are very unique in a binary. And these strings can be easily found using utilities and different tools present in our environment, like testing utilities, which we will be seeing in few minutes. And other than this, there are many common malwares which uses and unique entry points and addresses or API calls. So we can also use them in our Yara rules. So let's look over first Yara rule. So basically Yara rule comprise of three common sections. One is meta, the other is string and the condition. And rule starts with the name of a rule. Like over here I have named it like a WannaCry. The meta section is the section where we place our arbitrary data, and the data arbitrary data like the name of an author or a date on which it was created, a unique identification value like MD5 sum or a hash value, so that other researchers can easily identify that for which malware sample the rule was created. And the next one is strings. So basically this is the section where we will be placing our strings. For example, this MS wins on cache counter mutex. So it's a string present. It's a mutex for a WannaCry malware. So we have this is if when we run this rule. So if a rule manages to find this string or this string present in a binary that which is running in our desktop or laptop, so the rule will trigger. So the trigger mechanism works on in the condition section. So basically if it go in brief, so if a condition $x is valid, the rule will trigger. So it's just simple. So the art of building a resilient rule. So this is the most important part of building an Yara rule. So the building mechanism starts with the analysis process. So in this we get a malicious binary and we will analyze it. In the process of analyzing, we have to target to find few strings which are very unique. So here we jump to our next section in the identifying phase. So here over here we will try to identify strings which we will be using in creating our Yara rules. And again we jump to our next, and we will using this strings which we have identified previously, we will create our rule. So after creating, we have to test. So basically testing the best way to test our rule is to create a database, a big database of malware samples with some uh, positive binaries or non-malicious binaries like I have created over here. Okay, so example DB. So the folder comprises of around 260 binaries and randomly few are malwares, few are ransomwares, few are trojans and all, and few over there are non-malicious, so that we can test our tools, which generates less false positive and which are more resilient. Okay, so after that, after testing all these rules, so we can deploy them in the IDS or SOC or any other operating mechanism which the firm is using. And then the last but the best one is to monitor our rule for any further updates. So let's where to look for the strings or the data which we will be using in for creating our Yara rule. So basically, tools like strings are very efficient for extracting data from a binary, and the utility is present for both the common environments, which are Linux and Windows. And to create code-based rules, we prefer a disassembler. Most common one is IDA. Okay, so let's move towards our demo, and we will now work with some live malware samples. So, okay, so over here we have 6 binaries, and using them we will create our Yara rule. Okay, so let's open a file. Okay, so basically what does this mean is we have to name a file and the extension should be Yara, and our okay, so we will start with rule and name of a rule. You can name it anything. I have just named it here when cry. And again, so Yara is basically much closer to a C programming. So we will see few things related to C in this in our Yara rules. Like the rules start with parenthesis and ends with parenthesis, similar to a C program. Okay, so next we have to place our meta section. Over here we will place our metadata or arbitrary metadata. Okay, so anything which we can add over here, we can like name of an author. You can name it anything. Okay, and the date. Okay, so you can place more few things which you require, like amplify name or any hash value or anything else. We will add only two over here. Next is strings. So this is the part, the important part. Okay, let me open it in another terminal. Okay, so let's start with some strings. Okay, so this is how we have to look for various strings in the binary. So over here, this is we found our first string. Okay, so this is there is no any legitimate DLL named as launcher.dll in the Windows environment. So there are high chances that this is a malicious or a evil one. So okay, so we will use it in our rule. Okay, so basically each string placed in a rule consists of a name. So like over here, I have named it as x1 because we will add few more strings. So 1, 2, 3 order, and all the strings have to be enclosed in double parentheses. Sorry, not parenthesis, double inverted comma. Okay, so let's look for few more. Okay, so you have to go in very detailed form while looking for a strings. You have to search in a pile of strings, just like over here. Okay, so there's an exe named exe, but it seems like it's a legitimate one, so you can ignore it. You can also ignore this days and months because there are many chances that they can be used in the legitimate processes also. So basically the main thing is we have to ignore the common ones and we have to look for the unique strings. Again, they are common, so we will ignore them and look for few more. Okay, we find the directory path over here. Again, we can use it as a rule. And as as I told, Yara is much similar to C, and C often uses escape sequences. So again, Yara also uses the same. So we will add our escape sequences in our root, and we will look for the next string. Okay, over here we can find the URL. So we use it again. Okay, so these are few unique strings. So yeah, we can use them too. So basically, Yara doesn't have any hard and fast rule about the amount of strings which have to be placed. You can add n number of strings like the amount we can find in in a binary. Like over here, this is the name of a mutex, so we can use it. There is a embedded binary also, so yeah, we can use it too. So let's copy it. Okay, I guess 6 are enough, so let's move towards the condition. Okay, so basically conditions in Yara can be defined in various ways, like any of one. This is the easiest one. So if the condition, this condition means if the rule will trigger if any of the one condition or more than one condition is, sorry, not condition, the string is present in the running process of a computer. So let's save it and look for few more. Like this one, but yeah, we will be looking for some IP addresses now. So if yes, we can find it or not. So I guess there is nothing much left. So we will look for different encodings. Encoding means over here we can see like the binaries have various encodings. So yeah, we can use this. The using the Linux utility have a plus point. So we can use like 7-bit, 8-bit or all. So we can get some more unique strings. So let's use some. Let's start with some 16-bit, and yeah, over here we can find an IP address. So let's add it on our and then escape sequences, and let's save it and test it. So the rule starts with the initials of Yara and then name of a rule and the location which we want to scan. I guess we missed something. Okay, so basically Yara have a good quality of defining in which line the error is. So let's look at in 7th one. Okay, that should be strings. If I can find this way. Just a second, I will stop uh, my screen share, and I guess there is some issue with my installation. Can you see my screen? Can I get a confirmation for our screen? Okay, I guess it's okay. So the issue was we have missed parenthesis. So let's check it now and see it works fine. Okay, so the issue was, I guess we have missed the parenthesis. Okay, so the rule has worked. So basically the rule starts with the initials of Yara, then the name of a rule and the location which we want to scan. So the six binaries are now confirmed that they contain this all strings present over here in our rule. So the rule works fine now. Okay, so let's look go into a different folder to look a completely different scenario of the rule. Okay, so let's start. So in this scenario, we will be looking on that a single binary is not enough to create a Yara rule, like previously we have done by using a single binary. Okay, so let's start. The meta, and okay, so let's look for strings. So in Yara, basically search of the way to search of strings through, as I told before, look for unique ones. So again, we will do the same over here. Like this seems to be the. So basically, the thing is, it's not always the same. They that the present exe or binary is malicious. So we have to look in them in such a way that we get our positive results. Like this, if we compare these two DLLs, the MSPCRT is from the legitimate one, and as I have seen many times that the legitimate DLL often ends with the in a lowercase as compared to the evil ones like over here. And we also have to look for, and if in this case this .dll, the evil one, have to be in the lowercase, so we will look for it. We will try to search and dig about the DLL. So this is the proper way, and then we can also look for few more strings in the binary. Like these two DLLs over here, they are the legitimate ones. So we can see that they use the lowercase extensions, and see, we can find a name. And again in binary too. So yeah, we can use it. See over here. And again one more DLL and few com uncommon strings. So yeah, we can use them. We can edit this string a little bit so that it works for us. Okay, I guess there is nothing much more left, so let's add a condition for this rule. Again, we can use the same one. Let's test it. Okay, if we ignore this, okay, There is a pre-created rule. This was the rule which we have created right now. So if the rule triggers for a single binary, but we have one more binary over there. So give and the 11 versions which I have created have both the malwares of same malware family. So I guess we should look. So in this situation, we will look for the strings in other binary too. So let's look into it. Then we have to leave this and look for few more. Okay, over here there are few uncommon ones. So we can use this because we can leave this because we have already done one, so we can use it over there. The DLLs over here seems to be legitimate, so we will ignore them and look for other two strings. It seems it's standard, so we will look for the other encodings now. So now it has a lot of PXEs present over there. So we have to look for something in common because many of them seems to be legitimate. So and it seems all are the legitimate ones, so we have to look for other strings. Okay, we found three. It seems to be some decryption of the ransomware, so we can add them. And let's save it and test it and Let's check does it work properly or not. And see it works fine now. So what we have done is we have looked for the strings which are present in both the binaries. So there are many chances that you will face a situation where we have to use multiple malware of the same malware family to create your efficient rule. So let's look into the different scenario where we will be creating a code-based rule, and this one, and let's create a file over here. Okay, so basically some links from the code-based rule. So the code-based rules are basically created using opcode bits, which we will as figure out from our using our disassembler. So let's create our common syntax, and then we will move into our virtual environment where we have a malware sample running in our IDA group. Okay, so one more thing, the this meta section is not important. Even our rule will work if we don't read it. So let's not edit in this rule. Directly we will move towards string. Okay, so the code based rules are basically the hexadecimal values. So to add hexadecimal values we have to use parentheses instead of double inverted commas. So let's move in a virtual environment. Over here, yeah, I have opened the binaries, and we can see over here use portion of the code is similar in both the different binaries. Okay, so this is what a code based rule is. We will use this opcode bits present over here and here, and the few code is different, like few bits of the codes are different, which are because of registers, and we can also look over further down that the code is again different. So this is what we have to look for, similar codes in the multiple malware samples, and using this similar strings we will create our code base rule. So let's start with using this opcode bits. So uh, over here this, and in this malware sample, the register values are different. Okay, so when the values are different, we have to wildcard them using the question marks. Okay, so let's go in the next line where C1 and C1 is similar. So again, the registers can be changed from binary to binary and compiler to compiler. So we will again wildcard that, and we will focus on our constant value, which is 0b. So again, we will add it, and the next one 0f, Okay, and then again this two are the register values. So it's not hard and fast rule. So we can add like this AF and we can wildcard this D1 and D7. So this goes different from condition to condition. So like over here we have D7 and D1. Even if we wildcard this and for wildcarding this one D1 and D7, we can wildcard the last portion of the opcode and it will work fine for us, or we can completely wildcard it too. So it's completely your call what you want to do in this situation. And then again, if we move in the next line, which is 39 and D5, and over here 39 and CA. So 39, and again, as it's a register, we can wildcard it because it can change from compiler to compiler. So it's time to place our condition, and as there is only a single string, so we will use that, and let's save our rule and try to compile it. And here have code, the rule which we have created using a code works completely fine. Okay, so let's test this rule in our malware database which we have created, and let's see that it works in this situation. Insert just to find two different binaries. Okay, so this is what we have. This is the way we have to test our rules using our pre-created database to test the efficiency of our rule. Okay, so I have a pre-created rule for lubricates too. So Yara, using Yara, you can also look for your lubricates or other post-exploitation softwares in our environment, which can be used in red team assessment to harden your defenses. So let's see does it work fine or not. Okay, let me explain the thing. Yeah, so this means that in this portion of the code, the rule will accept any value from 0 to 3, same goes above. So these are some best things which supports Yara, supported by Yara in our hunting. Okay, so let's test this, and you will see that does it work. Yeah, it works for our binary, completely works fine. Okay, so let's move further. So an automatic tool for generating Yara rules. So we have basically two common tools, which is YaraGen, which was developed by Florian Roth, and then another one is Yara Generator. So both are best in their working, but the most preferred one I will say is the Yara because it uses a huge string database like over here which we have created for malware samples. The Yara similarly Yara uses a big database of strings to create some best tools, and I would suggest you should try both of them and see which works fine for you. So final thoughts: look for while creating Yara rules, look for unique strings and similar codes, and in the code base rule, wildcard the things that can change from various binary to binary, like the register values. And for testing, just create a big collection of malware samples and some non-malicious files like over here. This is a small database. I would suggest you should use something much bigger than this for testing your rules. And that's from my end. Any questions? Okay, I have any, and you can ask questions if you have. Am I audible? Hello. Do you have any questions? Okay. So, do you have any questions to ask? Feel free to ask them.
All right, thank you so much,
Okay.
Lakshya. That was good. We always love Yara here.
Okay, there's one question. Yeah, we can say that it's not an standalone tool, but yeah, it's a great for using in endpoint security, as the rules can be parsed using all the many common IDs supports Yara and other many tools like we have many common tools based on Yara also. So like Cuckoo Sandbox and many threat hunting platform supports it. So yeah, it can be used in endpoint security too. Okay, Yara. I have not tried Yara for detecting phishing email campaigns and emails, but yeah, I can guess it can work because if you use the strings which are present in a phishing email or phishing campaign, yeah, I can say that it will work. But yeah, I will not. I'm not 100% confirm about it. Would like to try this. Thanks for this one. I like it. Okay. Is there any other question?
All right, perfect. I think that's it, Lakshya.
Okay.
If anyone does have any additional questions, please post them up on the Discord
Yeah,
channel
yeah,
for this talk.
yeah, yeah. Sure.
Uh,
I will look over them.
yep. Other than that, thank you so much, and
Thank
we'll
you.
get ready for our next speaker.
Okay. It was pleasure speaking with you. Thank you.
Thank you.